there, it's Mrs. Lindquist. So today we're going to talk about family of functions and the graphs associated with them. So we're going to look at this first graph, and the family that this graph belongs to is linear since it is a straight line. And the parent function for all linear functions is f of x equals x. So your x is equal to your y. So you have 1, 1, 2, 2, 3, 3, etc. For this graph, we're going to assume that this graph continues infinitely in both directions. So when we talk about domain, we're talking about x, or how far the graph goes to the left or to the right. As we can see, this graph is going forever to the right, so it's going to positive infinity, and the graph is also going forever to the left. So my domain would be all real numbers, but we're going to do this in interval notation. So negative infinity to positive infinity. And again, it's the same thing as all real numbers. So when we take a look at the range is our y values. We can see this graph is going to go up infinitely, and it is also going to go down infinitely. So my range is also going to be all real numbers, so negative infinity to positive infinity. And again, for our infinities, we use parentheses to show there's no bound. So let's talk about increasing, decreasing. So for increasing, decreasing, we always start on the left side of the graph, and we can see that as we go to the right, the y values are going up. So this graph would be increasing. It increases here, and then it also just keeps increasing at the same rate. So for increasing, we always do it for intervals of x from negative infinity all the way to positive infinity. So as we read the graph from left to right, we can see the graph is always going up. So negative infinity to positive infinity. So when we look at decreasing, we can see that this line is strictly increasing. So for decreasing, you can just put none. And extreme values, do we have any maximum or minimum y value? And for this graph, since the graph goes up forever and down forever, I would say none. In our end behavior of this graph, the left end is pointing down to negative infinity. The left end is going down, and the right end is pointing up. So it is a down up for the end behavior. And again, we'll get into the better notation for that later. Okay, the second graph we're going to look at is this V-shaped graph. You might recognize this graph as being an absolute value graph. And the parent function for this graph is f of x equals the absolute value of x. So when you take the absolute value of -1, that's why your output is a positive 1. So the outputs are positive on both sides. So let's look at domain. We're going to assume that this graph goes on infinitely. So we can see the graph is going to the right forever and to the left forever. So domain would be all reals. And when we look at the range, we're looking at the y values. So we can definitely see that this graph is going up infinitely. It's going up over here and over here. But what is the lowest y value on the graph? Well, the lowest y value is 0. So everything from 0 up to positive infinity. So I would say 0, infinity. Now, are we including 0? Yes, because 0, 0 is on the graph. So we will use a bracket, and again, positive infinity is going to be a parenthesis as it cannot be included. So let's take a look at increasing, decreasing. So from left to right, we can see here that originally our graph is decreasing. The y values are getting smaller, and then once we get to our vertex, then the y values start going up. So again, when you do increasing, decreasing, it's always intervals of x. So we're decreasing here. So on the x-axis, we're decreasing from x being negative infinity all the way till we get to 0. So from negative infinity to 0. And we're not going to include 0 because at 0, the graph is neither increasing or decreasing. So then from 0 to positive infinity, we can see our graph is increasing. So 0 to positive infinity. Extreme values, do we have a maximum or minimum y value on the graph? And yes, we do. The lowest point on this graph is 0. So we have a minimum at 0. which is y equals 0. And our end behavior, both ends are going up to positive infinity. So our end behavior would be up on the left and up on the right. What is this graph, this U-shaped graph? Again, we're going to assume that it goes on infinitely. Do you recognize this as being a parabola? And the name of that is quadratic. And the parent function for all quadratics is f of x equals x squared. So again, when we take 0 and we square it, we get 0. 1 squared is 1. 2 squared is 4. Negative 1 squared is still 1, is up to 1, and so on. So go ahead and pause this video, see if you can fill in this information about this graph. All right, so let's look at domain. The graph is going to the right infinitely because we can see it is getting wider, so it is going to the right. And it is also going to the left infinitely because it's getting wider that direction. So domain is negative infinity to positive infinity. So now let's take a look at range. This graph goes up to positive infinity. It's going up on both ends, and the lowest it goes is 0. So everything from 0 up to positive infinity. So we would write that as 0, comma, positive infinity. We are including 0, so I will use a bracket. All right, let's take a look at increasing, decreasing. As we start on the left, from here all the way to 0, we can see this graph is coming down. So we have decreasing, and then once it hits 0, 0, then it begins increasing. So from negative infinity all the way to 0, we have decreasing behavior. And then from 0, positive infinity, we have increasing behavior. And again, those should both have parentheses. Extreme values, the lowest y value on this graph, we have a minimum, and the lowest y value is 0, which is y equals 0, and our end behavior is up, up. And this example was very similar to the previous one, so let's try a couple others. All right, so have you seen a graph that looks like this before? Kind of like a snaky looking graph? This graph is called a cubic. And the equation would be f of x equals x cubed. So 1 cubed is 1, 2 cubed is 8 off the graph, and so on. So if we look at our domain, we can see the graph is going to the right forever, and it is also going to the left forever. So domain is all real numbers. And the range, you can definitely see the graph is going up forever and also going down infinitely. So the domain and the range are both all real numbers. So let's read our graph from left to right. The y values are increasing on that part, and then it kind of turns and it continues to increase. It is strictly increasing. So from negative infinity all the way across the graph, we are always increasing. So from negative infinity to positive infinity. And then what about decreasing? Well, we just said the graph is strictly increasing, so for decreasing we should say none. Extreme values. Do we have a maximum or minimum y value? Since the graph goes up infinitely and down infinitely, I would have to say none as well. And the end behavior, the left end is pointing down to negative infinity and the right end is pointing up to positive infinity. Okay, so this graph is actually a graph of exponential growth. We'll call it an exponential function. So there is exponential growth, and then there is also exponential decay. The equation for an exponential function is going to be of the form of some number to the x power. In this particular example, we have f of x is 4 to the x power. Since 4 to the first power, if I put in a 1, that's going to be 4. And then the next value would be 4 to the second power, which my y value would be 16, and so on. So basically, the y values just keep multiplying by 4. So they'll go to 1 to 4 to 16, etc. So our domain, the graph is going to the right forever, positive infinity, and it is going left forever as well. Range on this one, let's take a look at that. The graph is definitely going up infinitely. How far does it go down? Well, it looks like it's going to go down to almost 0 because this is actually an asymptote line, so it is never going to get to 0. So basically, it's going to be everything greater than 0 to positive infinity. We'll have 0, positive infinity, and this time we are not going to include 0, since this graph, as you go to the left, becomes smaller and smaller, but never actually gets to 0. Okay, so let's read our graph for where it's increasing and decreasing. So if we start on the left and go to the right, we can see the y values just keep increasing and increasing. It's increasing the entire way on the graph. So from negative infinity to positive infinity, we have strictly increasing behavior across the graph. So decreasing, we would say none. Extreme values, do we have a maximum or minimum y value? Our y values are approaching 0, but they never quite get to a minimum of 0. So I'm going to say none on this one. So when we look at the end behavior, we can see the right end is going up infinitely. We can see the y values as we go to the left are getting closer and closer to 0. So I would say the end behavior on the left, the y values are approaching 0. So a little strange looking, but that's how the graph would look. So for this last example, this graph starts at 0, 0, and it kind of goes to the right. This is actually the graph of a radical or square root function. And the equation for this one happens to be f of x equals the square root of x. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and so on. Go ahead and pause this video and see if you can fill these in. All right, so let's look at domain. We can definitely see this graph goes to the right forever, but the lowest it goes is 0. So domain would be from 0 to positive infinity. And we are including 0 since the square root of 0 is 0, it is included. Now let's look at the range. The y values are going up infinitely. I can see this graph is going up, and the y values are going down to 0 again. So 0 up to positive infinity. All right, let's read our graph from left to right, and we can see that our y values are strictly increasing. So from x equals 0 to positive infinity, we are increasing. And again, we are not including 0, since at 0 we are not increasing or decreasing at that point. Decreasing, we would say none. Extreme values, do we have a maximum or minimum y value? And I would say yes, the lowest y value on this graph is 0. So we have a minimum y value of 0. And the end behavior, you can see the right end is going up, and the left end, well, it's just at y equals 0. So there you go. So I just want to take a look at number 3 on your homework. Since this is a V-shaped graph, it will be absolute value. Domain, we can see, is going from positive infinity to negative infinity. So let's take a look at the range. So if we take this top point and drag it over to our y, we can see the highest this graph goes is y equals 2, and then the graph goes down from there. So everything 2 and below to negative infinity. So I would say negative infinity up to 2. And we are including 2 on the graph. So let's label our increasing, decreasing. So we look on the left, we see the graph is increasing. And then once it hits this point, it begins decreasing. So when we read the graph, we're going to read the graph starting on the left. So from negative infinity all the way till we get to this point. So from here all the way to negative 3, our graph, as we read to the right, is going to be increasing. So negative infinity to negative 3. Once we pass x equals negative 3 and keep going to the right, is now the graph is decreasing. So it's decreasing from negative 3 all the way to positive infinity. Extreme values, do we have a maximum or minimum y value? If we look at this graph, we can see our maximum point is y equal 2. We have a maximum of 2. And the end behavior, both ends are pointing down to negative infinity. And so that's a wrap. So hope you guys have a great day.